What's up guys, this is Felipe here. In this video we are going to solve the following trigonometric identity from both sides. We know that usually a problem that consists of proving a trigonometric identity, we usually start from either the left side of the equality or the right side. In this case, for showing that we can reach the same result, we are going to prove the trigonometric identity from each side, from the left and from the right. So in this case, we are going to start from the left side, and we can see that we use a technique which consists of multiplying the fraction with the same expression in the numerator and in the denominator. This is the same as multiplying the fraction 1 minus sine of x divided by cosine times 1, because if we multiply something by 1, it's the same as multiplying it by nothing. And then we replace the 1 by the fraction by the conjugate of the numerator, because this is 1 and then we can cancel and then it's the same expression. Okay. Next, once we have multiplied the original fraction by the conjugate is the same expression but with the sign different. Then we proceed to multiply both fractions. So we end up with this. We end up in the numerator with a product of two binomials, and in the denominator we also end up with a product of cosine and 1 plus sine. Then using algebra, we know that the product of two conjugated binomials is equal to the difference of squares, which means that we have 1 minus sine of x times 1 plus sine of x. The two expressions are equal, but they only change in one sign. Then we can apply the following rule, that a plus b times a minus b equals e squared minus b squared. So we end up with 1 minus sine squared. Okay, and we remain the denominator the same. Then we apply the trigonometric identity 1 minus sine squared equals cosine squared. So we simplify this addition of two terms into one term. Okay, and then we can cancel these two in the numerator with the cosine in the denominator, and we end up with only one cosine. And we have reached our answer. So we have proven the identity from the left hand side. Now let's do the same but from the right side, right? Because we are trying to see if we can reach the same answer from both sides. So we can click this select and change the method specifying to solve from the right side. So we click here, and there we go. We also have achieved our answer. Let's see how is the step by step. We start from the right side, which is cosine divided by 1 plus sine, and we apply the same trick. We multiply by 1 minus sine of x divided by 1 minus sine of x, which is the same as multiplying by 1, right? We multiply by 1 and then we replace the 1 by a fraction of the same thing in the numerator and the denominator, because it's the same. It's like we are multiplying by 1. And we also multiplying by the conjugate of the denominator, right? In this case, we are multiplying by the conjugate of the denominator because in the numerator we don't have a plus sign, right? So in order to multiply for a conjugate, we need an addition of at least two terms. So that's why we are choosing here the conjugate of the denominator. So now we proceed to multiply both fractions. So we end up in the denominator with cosine times 1 minus sine of x, and in the denominator we end up with a product of conjugated binomials. So we then apply the same rule, a plus b times a minus b equals a squared minus b squared, which end up with 1 minus sine squared, which we can simplify to cosine squared using the identity 1 minus sine squared equals cosine squared. Then we proceed to cancel the cosine in the denominator with the cosine squared in the denominator, and we end up with 1 cosine in the denominator, and we have reached our answer. So, conclusion, we have proven that we can prove the same trigonometric identity from both sides. So that will be, let me know in the comments below if you have any questions. I hope you like the video. Please give it a like and subscribe, and I will see you in the next one. Thanks, bye.